So this problem says we have a particle of mass m and charge q. It's moving in a region where we have uniform electric field as well as magnetic field. So let us say what we have. So we can make the diagram first. This problem says, let us say this is my x-axis. In this direction we have velocity, we'll discuss. This is my y-axis and this is my z-axis. So let us say this direction we have electric field as well as magnetic field, both exist in this direction. They are parallel to each other. Now question says at t equals to 0 the velocity v naught of the particle is perpendicular to the electric field. So we have a particle that is given a velocity v naught. So this particle at t is equals to 0, let us say at origin, and this has been given a velocity v naught perpendicular to the electric field. So this is my electric field and this is my magnetic field. So this is in the y direction and velocity is in the x direction. Now we have to assume that v is much less than c, so that we are not entering the space of relativity. Find the velocity of v of particle in time t. So what we have to find is, we have to find velocity of particle as a function of time. So that after any time t, what is the velocity? This we want to find out. And now we have to express the answer in terms of velocity vector v naught, e and b. So let us try this one, how we will proceed. You see, it's easy. If there is no magnetic field, so let us decompose this problem into two parts. So first part, if there is no magnetic field, only electric field. So if I say, if there is only electric field is there, so I can say only electric field, only E, no B. This means, now if I leave this particle here, there is a force in this direction Q into E. So what is the force? So force will be Q into E. So this is the force on particle. What is the acceleration in the y direction? So this is my y axis. So I can say this force in the y direction. So acceleration in the y direction I can calculate. That is nothing but QE divided by m. So this is the acceleration in the y direction. So I can calculate velocity in the y direction. So Vy is equals to u, initially u in the y direction is 0 plus a into t. Now a is nothing but QE by m and this into t. So now I know what is the velocity in the y direction. This is simply Vy is equals to QE by m into t. And now the E vector and y vector both match it. So simply if I write QE vector, so this means it will give you the velocity in the y direction, that is with a vector sign. Now let us say if I have only magnetic field, no electric field. So this time I am decomposing the problem. If I have only magnetic field and this time no electric field. So electric field is 0 this time. What you will have, what kind of motion you will have, try to analyze. You see, here we have, if I leave this particle with velocity v naught in this direction, and there is a magnetic field in the upward direction, so magnetic field also in the upward direction we have. So there will be a force on this particle QB cross V. So V is this side, V is up. So QB cross V will come outside the plane, that is a z direction. You can verify yourself using right-handed thumb rule, or you can verify yourself. So if you move your finger from V to B, so this is thumb, if you move from V to V, the finger will come outside. Are you getting or not? So thumb will come outside. So velocity vector and electric field are oriented in this way, so force will be oriented in the z direction. So now I know. So magnetic force, so in this case magnetic force is oriented in the z direction. Magnetic force is acting along the z direction. Is acting along the z direction. Along the z axis. Are you getting it? So this is positive z axis. So this is acting along the positive z axis. What is the magnitude? Simple. That is Q V cross V. So F is equals to Q V cross V. And initially this will be V naught. Now I am only interested in the magnitude part, so I can write force magnitude. This is equals to Q V B, and V is basically V naught, and this is acting along positive z direction. So this is along z axis. Along the z axis. Now you see what will happen if you have this force. So this particle will come this side, and if you don't have any electric field, only have magnetic field. So what will do? This particle will basically do a SHM. So this will come here, and so not SHM. This will move in a circular path. So this will come here, and this will follow something like this. So this will complete a circle, in XZ plane. So this will move. So if I have something like X and Z. So this is my X and this is my Z plane. You see t equals to 0, this particle is here, and t is equals to 0 plus the force is acting along the Z direction. So what will happen? You try to analyze. So this force will come this side, and this force is this side, and now it will move. So slowly it will complete a circle. Are you getting or not? Let us analyze the motion. So initially this particle has been thrown in the x direction, and the force is acting in the z direction. So what will be the motion? And I know this has to have a circular motion. So it will deflect something like this. So initially it is thrown in the x direction. So after some time it will be here. After some time it will be here, here. So it will follow a circular path, and this will come along the same line. So this is the circular path you will have. Are you getting or not? So basically it will make a circle in XZ plane. Initially it is thrown this side, so it will deflect in the Z direction. So it will follow a circular path in XZ plane. So circle is in XZ plane. So if I see the same thing, so XZ plane, it has to follow a circular path in XZ plane, and the motion is from here to here. So you have initially X equals to 0. So particle is moving in this direction. So this means X to Z. So this is going along the X direction, and then it is going along the Z direction. So the particle is something like moving something like this. So this point. So I can make, and finally it has to come up to this point. So this is the motion in XZ plane. Simple. So this is the motion. You see, this is not perfect circle. It has to be perfect circle. So this is the motion. Now we can calculate what is the time period. So at any point of time, this particle is here. So let us say at any time t, this particle is here, and the velocity is along the tangent direction. If I calculate what is the angle made by this with the x-axis, and we can calculate what is the x velocity, what is the y velocity. Only thing is I have to calculate this angle theta. Now you see, this is basically revolving, let us say, with radius. I know radius is mv by qb, and time period I know that is 2 pi m by qb. So basically now I can calculate omega, what is the angular velocity by which it is moving. So time period is nothing but omega by 2 pi. So from here I can calculate omega, that is 2 pi into t. T is equals to 2 pi by omega, something wrong. So this is 2 pi by omega. So now I know what is omega. Omega is nothing but 2 pi by t. So if I plug this value 2 pi by t, and t is nothing but 2 pi m by qb, so 2 pi m by qb. So you have omega, that is nothing but qb by m. qb by m. So now if this at this point is moving in a circle with an angular velocity omega. So what is the angle made by the center by this particle? So what is this angle at any time t? So now I know this angle has to be omega into t. So theta is equals to, acceleration is 0, omega t plus half alpha t square. Alpha is 0, so theta made by this point that is a moving charge particle at any time t is omega into t. So now this theta, I know this theta is omega into t. And now this theta and this theta is equal. You can prove yourself. This line is perpendicular over this line, and this line is perpendicular over this line. So this is my omega into t. Now I know everything. So this is my velocity v, and this angle is theta. So what is Vx? V cos theta. So Vx is v cos theta. And I know the initial velocity is v naught, velocity does not get changed, only the direction changes. So Vx is v naught cos theta, and theta is nothing but omega t, and where omega is given by this formula qb by m. So this is Vx. What is Vz? So Vz is, you see, this is v naught sine omega t, so this is sine theta. Vx is equals to v sine theta, sorry, Vz is equals to v sine theta, and theta is omega t, so I can plug this value, and v is v naught, it remains constant in circular motion, so v naught sine omega t. So this is the velocity in the x direction. Now if I superimpose these two situations, so what we have? So we have situation something like this. If there is no electric field, no magnetic field, only electric field, this charged particle will move along the y direction. It is here, and the velocity is given by Vy. So this is x, this is y. So if there is only electric field, you have electric field but no magnetic field. This time no magnetic field, our motion is a straight line, and velocity is given by qe by m into t. So qe by m into t, magnitude wise. So this magnitude of this is qe by m into t in the y direction. If you have only, this time only magnetic field, no electric field, so if we have only, so this is your x-axis, this is your y-axis, and this is your z-axis. If you have only magnetic field, no electric field, so this time no electric field. Of course, electric field and magnetic field both are in the y direction. So in this case again, this is B is in the y direction, electric field in the x direction. Sorry, this is in the y direction, again this is in the y direction. So we said in this case you have a motion that is in xy plane, so you have somewhere here. So the motion is in xy plane, circular motion in xy plane. And we shown velocity of x component of velocity and y component Vx is given by v naught cos omega t. So Vx is basically, okay, let me put these dots here. So Vx is given by v naught cos omega t, and Vz is given by v naught sin omega t. So this is v naught sin omega t. Now what will happen if I apply both? So now third situation, we apply both. That is superposition principle, because B does not affect electric field and electric field does not affect the magnetic field motion. So these two motions are independent motions, so we can apply superposition principle. So if we apply superposition, what I will have? So if we apply superposition, I can write total velocity, that is nothing but Vx plus Vy plus Vz. Are you getting or not? So Vy we already know, that is qe by m into t. So Vy is nothing but qe by m into t, and this is qe. So Vy I am writing. So let us say first write Vy. So I can write Vy. So this is I vector, this is j vector, and this is k unit vector. So I can write Vy j plus Vxi plus Vzk. Vy is equals to qe by m into t. So qe by m into t. So this is Vy j vector plus what is Vx? V naught cos omega t, and this is I vector. What is Vz? V naught sin omega t, and this is k vector. Now things are easy, and you can basically write j vector and e vector. If I multiply e into j, so this becomes e vector. So this is qt by m, and this becomes e into j, that is vector e. So this is unit vector. because E vector is along the z direction. E vector is along the z direction, so I can multiply. Now what is this? I. What is I vector? I vector is same as initial velocity vector, V naught vector. So I can write V naught into I is simply V naught vector. So this is V naught cos omega t plus. What is vector k? So vector k is nothing but, so you have V naught, this is V. So V naught cross B is k, j vector, z vector or k vector. So you can say V naught cross B is k vector. I can write here itself. So what is unit vector in the k direction? So V naught cross B, or E you can also write, divided by magnitude of V naught cross B. So this will give you the k vector, V naught cross B. So I can write this vector V naught sine omega t, and V naught cross B, this is V naught cross B divided by magnitude of V naught cross B. So this is the final velocity we'll have. Basically you can do this problem by using the writing equation of motion, and then you can solve differential equation for x, y, z direction, but that will be a tedious task. You see, if I try to see what is the overall motion, it's a good idea to see the overall motion. So if you see the overall motion, how it will look. So it's a spiral kind of thing, it's easy. So this will go something like this. So this is moving along this line, but it's also moving in the bidirection. Are you getting? So it is also moving. So this will having a spiral path. So you will having something like this kind of thing. So situation is something like this. So it is moving in xz plane, but slowly it also moving along the bidirection. So it is also moving in the bidirection. So I have to make something like this so that you can understand. So this is also moving in the bidirection. So the motion is a spiral kind of thing, or you can say shifted helix. Are you getting it out? So this is a pitch. Somebody say find out the pitch of this problem. You can find out the pitch because you know the velocity V vector, you know the time period, so you can calculate pitch. So you calculate yourself what is the pitch. And this pitch should be constant. It should depend upon time, or it should constant. It should depend upon time because velocity in the y direction depends upon time. So pitch will be not constant. It has to be a function of time. So calculate pitch as a function of time. Calculate pitch as a function of time. And you prove that this pitch is a variable. It's not constant pitch.